Okay, hello students. In this class, we will review pointers and talk about references, which is newly introduced in C++. The concept of pointer is same as C programming language, so I am expecting you to know pointer already. So in these sessions, I will briefly review the pointers. Okay, let's start. A pointer is the memory address of a variable. A pointer gives you more low-level control of the computer memory, which is very powerful, and that is the reason why we use C and C++ in embedded system. And unlike other primitive data type, pointer variable stores the address of memory. For example, variable type int stores the actual value of type int, but the int type of pointer stores the memory address where the actual int type of values is stored. So we say pointer variable holds pointers to int, double, and so on. To quickly review how to declare the pointer variables, Robert and Williams are ordinary int types of variables, and Bob and Jason's are pointer variable, which stores the pointer to int variable. To declare pointer, you just add asterisk before the variable name like this. This ampersand is called address of operators. Using these operators, we can obtain the address of the variable. So in this example, Robert is ordinary int type of variable, and Bob is the pointer variable, which can hold point to int type of variable. In this example, Bob points to Robert's variable because we assign the address of Robert's variable using this address of operators. Similarly, Jason pointer variable points to the William variable. So if we change the value of Bob, the value of Robert will also change accordingly. When we are dereferencing the value that the pointer variable points to, we use this asterisk, which called dereference operator. We use this operator to access the actual value that the pointer variable points to. So here, because Bob is pointing to Robert variable, and asterisk Bob here accessing the value of Rob variable. So this one and this one produce the same output. Can you notice some strange things here in this code? Here we use asterisk when we are declaring pointer variable, and here we are also using asterisk when we are dereferencing pointer variable. So they are asterisk, but have different meanings. So this is very confusing if you look at this first time. To avoid such confusing in asterisk, it is good practice to distinguish them. So when you declare the point variable, put asterisk next to the type like this, not like this one. So by doing that, you can distinguish asterisk for declaring pointers and dereferencing pointer. This is a good practice. This diagram shows the differences between pointer assignments with asterisk and without asterisk. For these assignments, assume that P1 and P2 are pointer variables and P1 is pointing to this memory locations where the 8 is stored, and P2 is pointing to this memory location where the number 9 is stored. So after these assignments without asterisk, P1 is pointing to the memory location where P2 points to. So it changes to this. So after this, P1 and P2 pointing to same memory location. So if the value of P2 is changes, it also affects P1 as well because they are pointing to same memory locations. But this changes if we put the asterisk here. So same as above, P1 pointing to here, P2 pointing to here. But if we assign with this assignment statement with the asterisk, P1 still points to these memory locations, but the value of P2, which is 9, is copied to this memory location where P1 is pointing to. So this is the differences between these assignments and these assignments. Okay, let's look at this pointer demo code. Pointer 1. So this is long code. So let me first compile this program and see the output of the program. So this is the output of the program. So there is 2 int type of variable a and b, which holds 3 and 5 respectively. And there is a 3 pointer 1, 2, 3, and pointer 1 is pointing to variable a, and pointer 2 points to the variable b, and pointer 1, the address of pointer 1 is assigned to pointer 3. So pointer 1 and 3 are pointing to same memory locations, which is the address of a variable. So if we print this, the reference operator with pointers, it prints the value. So because pointer 1 and 3 pointing to the same memory location, so it prints same values, which is 3. And pointer 2, because it's pointing to the address of variable b, pointing to 5, which is different value. And if we print the address of these pointers, as you can see here, pointer 1 and 3 pointing to the same address locations. This address should be the address of variable a, and pointer b is pointing to different memory location, which is address of variable b here. And one thing to notice is that even though pointer 1 and 3 pointing to the same memory locations, the address of pointer itself, which is pointer 1 and pointer 2, the address of pointer 1 and pointer 3 variable is different here. Pointer 1's variable, address of pointer 1 variable ends with 518. The address of pointer 3 variable ends with 508. So you should know these differences. Even though they point to the same memory locations, the actual memory address of these pointers are different. And below here, we assigned, there is assignments. We use asterisk here. So value of pointer 1 is copied to pointer 2. So here, before pointer 2 was, the value of pointer 2 was 5, because we assigned the value of pointer 1 to pointer 2. Value of pointer 2 now is 3. But as you can see here, the pointer 1 and 3 pointing to the same memory location, but pointer 2 is pointing to different memory locations, to these two, pointer 1 and 3. So this one, because of these dereference operators, address is not copied to this pointer, but the value, which is actually stored in this pointers memory pointing to, are stored into this pointer variable. So that's the difference between these assignments and this assignment, and you should know that the address of pointer is different, even though they can pointing to the same memory locations. Okay, so let's go back to the slides. Okay, so we can also perform arithmetics on pointers, but this is addressed arithmetics. So let's run this example code and see the output. So here we have an array which holds 5 int value. Array is a pointer, so we are doing +1 arithmetics on array, +1 and +2. If we look at the output of this program, the address of this array pointer array is end with F640. 640. So, and here we +1 with this pointer, it becomes 644. This is strange because 640 +1, it should be 641, but the output is 644. And if we +2, it becomes 648, not 645. Why this is happening? Because this is addressed arithmetics. The arithmetic results of pointers are different depending on the basic type. Because this pointer's basic type is int, and because size of int is 4 bytes, when we +1, we are adding 4 bytes here. So 640 +4 is 644, so it becomes 644. And if we add 2, we are actually adding 8 because 2 times 4 is 8. So it becomes 648. So you must know that arithmetic results of pointers depending on the base type. Okay, let's go back to the slides.